Look, right now, a silent execution is happening in the back rooms of the global economy. Nobody's dying, no. But certain major sectors are being deliberately starved. So who's making this choice? And based on what? And more importantly, which side of this invisible list will your next major allocation fall on? Let's step into that dark room where it's not money but capacity being rationed. Let's be honest, if you think the semiconductor crisis is over, you're probably looking at mainstream media's rosy picture. The headlines talk about logistics, containers at ports, but today we're examining a far more brutal, far more rational process: margin cannibalization. So what is this? Let's look at the math. Imagine you're a foundry manager. Your capacity is limited, your machines run 24/7, and you don't have a single empty slot. Two orders are sitting on your desk. On one side is NVIDIA. They want your most advanced AI chips, and they're leaving you exactly $25,000 profit margin per wafer. Yes, you heard that right. A single wafer, $25,000 pure profit. On the other side is an automotive giant. They're waiting for you to produce sensor chips on your old but reliable 28 nanometer plus lines. But what does this job bring you? Just between $1,500 and $2,500. Now ask yourself this question: which would you choose? $2,500 or $25,000? The answer's pretty clear, right? This is what we call invisible rationing. Fabs are making a choice today, and in that choice there's no room for low-margin sectors like automotive or consumer electronics. They're literally condemning them to starvation. Look, this isn't just a simple supply-demand issue. This is a deliberate operation by giants like TSMC to protect, or even push higher, their 48.5% operating margins. For a foundry, this is node arbitrage strategy. Cut what's unprofitable, prioritize what's profitable. The result? While the AI world grows rapidly, advanced chips climbing at a massive 37% in 2025, those old but vital chips powering our cars are only growing 7.75%. That 5 times gap is actually the map of tomorrow's bottleneck. Bottom line, the issue isn't that you can't find chips anymore. The issue is that the chip you need isn't wealthy enough to sit at that valuable table in the fab. So where is this starving automotive sector being driven? Why are waiting times measured not in weeks but in seasons? Let's look closer at that dark picture, at automotive's hunger line. So how does this margin cannibalization affect the person on the street or your portfolio? Let's examine the automotive sector, that vital artery of the global economy, that massive $116 billion hunger line. Look, here's the biggest tragedy. A modern electric vehicle consists of thousands of chips, but two-thirds of these chips depend on those old 28 nanometer plus nodes that fabs now avoid investing in. Now let's analyze this terrifying gap together. Looking at 2025, we see advanced chips used for AI and high-performance computing, HPC, growing 37%. But what about those mature nodes used by cars, appliances, that basic infrastructure? They're only growing 7.75%. That's a 5 times divergence. So the world wants smarter, more autonomous vehicles, but the production capacity for the chips that run these vehicles is literally being crushed in the shadow of AI chips. Fabs are deprioritizing these low-margin lines to dedicate that same space to much more expensive AI wafers. The result? A silent production crisis. The numbers you haven't heard in the headlines actually tell the whole story. Lead times for mature node logic and analog chips have now climbed from 12 weeks to over 20 weeks. If you're building an electric vehicle, EV platform, the situation's even more brutal. Delivery times for power electronics and MOSFET inventory have exceeded 25 weeks. Think about this. Today, if a Tesla or Ford production line is waiting for a part, that part is probably some simple $2 sensor chip that TSMC or Samsung threw to the back of the line as low margin. Automakers are now desperately trying to stockpile, hoarding MOSFETs. But this just delays the problem. Because this is a capacity allocation war, and as long as automotive giants can't pay the high rent that NVIDIA pays, they'll always be the hungry party at the table. So why don't these companies just build their own fabs and solve this problem? Why do they have to just pay rent? That's where the semiconductor world's brutal feudal rent system kicks in. Let's examine why even Nvidia is actually just a tenant, and whose coffers the money really flows into. So while automotive giants wait at the door, where are the billions from AI giants flowing? Let's examine the semiconductor world's rarely discussed but most brutal hierarchy. Most people think Nvidia or Apple are at the top of this sector, but let's be honest, they're just the knights of this story. Yes, they design amazing products, but even they have to pay billions annually to the true feudal lords. There are two main gatekeepers here, TSMC and ARM. Let's start with ARM. Look at this number, 87.98% gross profit margin. This is a ratio with almost no equal in the financial world. ARM doesn't actually manufacture anything, they just draw that architectural blueprint for how chips should be made and collect license and royalty from each chip. By 2030, royalties from data centers alone are expected to exceed $1.5 billion. Then sitting at the other end of the table is TSMC. In Q1 2025, TSMC's operating margin came in at 48.5%. How do they so easily crush the sector average of 36.75%? Simple answer, node arbitrage strategy. TSMC deliberately deprioritizes old production lines, legacy nodes, with low profitability. In their place, they focus on advanced 3nm wafers. And what do they price these wafers at? Hold on, between $25,000 and $27,000. That means an average selling price 2.5 times higher compared to mature nodes. This is exactly what feudal rent is. Apple pays TSMC $22 billion annually just to access this production line. Nvidia pays approximately $20 billion. These giant fabless design companies, yes, they create high value, but they have to give back $40 to $50 billion of what they earn each year directly to these gatekeepers, TSMC and ARM. This is a system where if you can't pay this rent or if your margin is too low, TSMC throws you to the end of the list as capacity allocation authority. The tragedy automotive giants are experiencing today is exactly this. They're the tenants who can't pay the high rent and therefore get evicted from the fabs. And here's the more interesting part. This rent increases every year because advanced packaging technology has now become a second foundry. As capacity remains tight, these gatekeepers' pricing power becomes even more cemented. But here's the thing, even this financial fortress, so profitable and seemingly perfect, has a major Achilles heel. Even if you have the money, even if you pay the rent, there's something that can stop the system. So what happens if you have $100 billion to build a fab but can't find the engineers to run it? Or if the tap on those rare metals that are the raw materials for chips suddenly shuts off? Let's now move to the weakest link in the West's big gamble, the talent and raw material crisis. So let's be honest, does having $100 billion in your pocket and buying that foundry entry ticket solve everything? Absolutely not. Because in today's semiconductor world, there's something money can't buy. Only time and ecosystem can build it. Operational excellence. America and Europe are trying to build their own fortresses with massive packages like the CHIPS Act. You can somehow find the money to build the fab, but where will you find the people and logistics to run those atomically precise machines at Taiwan efficiency? This is where the term investors fear most emerges, frontier tax. This is the bill for stepping outside the developed ecosystem, for moving production from that safe Taiwan harbor to the West. The numbers don't lie. A fab built in America has operational costs, OPEX, 35% higher compared to Taiwan. Why? Because it's not just about salaries. In Taiwan, labor represents only 10% of total operating expenses, while in America, that ratio jumps to 30%. Plus, TSMC, to retain its talent, has initiated an impossible wage inflation spiral by increasing salaries 44.5% over the last 5 years. Bottom line, those magnificent facilities being built in Arizona or Europe risk remaining very expensive geopolitical insurance policies rather than profit centers. The West is willing to pay this frontier tax cost, but this cost creates insidious pressure on the profit margins of giants like Nvidia and Apple. So where are these structural costs and margin cannibalization taking us? Where is the investment trajectory shifting? Let's conclude this part of the series with the final piece of this complex picture, the Great Divergence. When we put this entire picture together, here's the reality. In the semiconductor world, it's no longer free markets but capacity rationing that rules. Look, what you need to watch as an investor is the Great Divergence point. In 2025, while the AI and high-performance computing AI/HPC market grows 37%, the rest of the world, those mature nodes running our cars and home appliances, are only growing 7.75%. That's a full 5 times divergence. This divergence is also changing capital's trajectory. The issue is no longer about selling products, it's about where you stand in the feudal rent system paid to lords to be able to produce that product. Giants like Apple and Nvidia are paying a large portion of their earnings as tax to gatekeepers like TSMC and ARM. But remember, this margin cannibalization and talent crises we discussed in this video are just the beginning. In the next video, we'll examine the darkest and harshest bottleneck of these financial fortresses. So what happens if you have your fab, your money, and your engineers, but China hits that famous kill switch? In 2026, we'll examine in full detail those gallium and germanium wars that could condemn Western production lines to zero output, those steel-like bottlenecks, in our next episode. Until then, remember, it's not money but capacity, and the raw materials protecting that capacity that represent real power.